All right, everyone, welcome back to our Geology Museum Annual House. I'm pleased to announce our next speaker. We'll be talking about 19th century geology and the creation of America's first geology museum. I'm pleased to introduce Dr. Lauren Adamo, who earned her bachelor's, master's, and PhD degrees in geological sciences from Rutgers University. She's currently an assistant teaching professor in the Rutgers Department of Earth and Planetary Sciences, as well as director of the Geology Museum. Her research focuses on understanding the causes of changes in climate observed through North American sediment cores over the last 200,000 years. She's also involved in various projects monitoring surficial and coastal processes using drones. Lauren spends a lot of time teaching, both formally as a professor of geoscience courses, as well as informally in the educational programs at the Rutgers Geology Museum. Now I'm really pleased to introduce Lauren and have you hear a little bit more about the history of this wonderful museum. Okay, Lauren, over to you.
Great, thank you, Kathy. Let me share my screen. I have to say it's a little weird for me being on this side of the talks because I'm usually the one running around like a crazy person at the open house, making sure everything is working. So it's a little bit of a role reversal for me. Anyway, so today I'm going to be talking about the history of the museum. This was a research project that myself and a couple other people at Rutgers took on back in like 2017, 2018, to really tell the story about how awesome our little museum is. So just to note, this is being recorded and live streamed to Facebook. I also, before I forget, Dr. Scott mentioned at the beginning that if you wanted to join and become a member, that is possible. So when you become a member, all people who become a member will get one of the Geology Museum 150th anniversary stickers, and then different levels you get. Here's our awesome new hat. It's hard to see what they look like in the picture, but they came out really nice. And then we have our really cool 150th anniversary tote bag. So just showing off the swag in case the little tiny pictures you saw on the screen were not enticing enough. So anyway, sign up to become a member so that you can get some of that really cool 150th anniversary swag. So who am I? Dr. Scott gave me a little nice introduction. So yes, I am the director of the Geology Museum. I have been in the position in various roles at the museum since 2009. Like I said, I also teach courses in Earth and Planetary Sciences. I study ancient oceans and isotope stratigraphy, also do a lot of fun stuff with drones. And my whole life, I've been a lover of museum science, communication, and science in general. I love dinosaurs, love teaching about dinosaurs. And I also have 3 kids, which takes up all the other time that I'm not focusing on the museum. So let me just preface this talk that I am a geologist by training, not a historian. So this project, this research project, was very much a joint effort between myself, some other geologists, and people who are more familiar with the history part of it. So I had a historian help us with this, and then also worked with someone in the library to help us sort through all the archives. So I do know this story, but there are parts of it that I probably don't know because I'm not a historian. So, but I'm going to try to give you put you in the framework of what it was like in the 1800s in terms of science and how that led to the formation of the Geology Museum. So the study of geology first started in Europe, and it came out of 3 fields that kind of came together. So the first one was more a philosophical debate. So this was carried on for centuries, where people looking at things that they find in nature and debating how old is the earth, how was it formed, and ideas like that. So trying to understand and unravel what had happened in the past was one part of it. The second part was the collection of objects, sort of what our last speaker talked about. So collecting minerals and fossils and other curiosities that became kind of the natural history, natural science of it. So people started amassing these large collections, and then ways to systematically study those collections came out of those early collections. And then probably the most influential one, because this is the one where there was monetary means attached to it, was mining. So people recognized that these resources from the ground were very valuable, could be used for many things. And so having a way to study that and study where the deposits are and map where the deposits are and figure out where there might be more of this valuable stuff was also very important at the time. So the United States, the first speculative geologic map of the North America was in the 1750s. So this was presented in Paris. It was mostly came about because of mining. They were speculating, okay, well, here's a map of the different areas, and these are the mining resources that could possibly be taken out of the earth in those areas. So it wasn't until after the American Revolution that the first, we say geological in parentheses, because it's not geology like we think of it today. It was more just, like I said, like, okay, here's different areas and here's places where we might find some different minerals. But all the earliest geologists were trained in Europe, and the geologists that started the field in North America, the United States, came over from places in Europe. So one of those such people was Samuel Latham Mitchell. He was one of the earliest and most influential geologists, especially in the United States. He was trained in Edinburgh, and he came to the United States in the late 1700s. And he actually published a book. You can see the title there, Geological Remarks on Maritime Parts of the State of New York. So why he's important, well, I'll show you some of his work, but he is credited, or it's not credited, but they think he's the first person to teach a geology, in parentheses, course in the United States. So in 1792, he taught a chemistry and natural history course at Columbia University. And like I said, this is probably the first time geologic concepts were taught in a university in the United States. So then we have William Mcclure in the early 1800s. He is very well known for publishing some of the most well-known early geologic maps of the United States. So his maps, you can see a picture of it here. They were published in Cleveland's geology textbook, which I'll talk about Cleveland in just a minute. But this map was published in 1809. These maps were hand-drawn by him and hand-colored. You can see they look sort of like intro to geology or structural geology maps that we do at Rutgers, where we color in the different sediments. And so these maps weren't just guessing, they weren't speculative, like, you know, we think that this stuff is there. They were based on actual observations that he himself made and traveled to places to make these observations, and on samples that he collected in the field, and also samples that were sent to him from other people around the country. So this is really the first attempt to try to classify the different areas of the United States based on the different rock types. And you can see there's a bunch of different colors here. So how he split this is the orange, he said, are the primitive rocks. And by primitive, he's most likely meaning the oldest rocks. The pink, which it's a little hard to see in here, but those are transition rocks, which I'm not exactly sure what he meant by that, but they're transition. Light blue are secondary. You can see that the way I interpret he's thinking that is that they came after the orange rocks. The yellow part on this map are what he interpreted as alluvial. So these are things that would be deposited by rivers or water deposition methods. And then the dark blue that he has here are things that are old sandstones. So here's another look. You can see a close-up look at the Northeastern and New Jersey. You can see some of these colors. So this was the first real attempt to classify not just based on what was there, but how they were formed as well. So this kind of laid the foundations of like how geologic maps would be made into the future. And so if you compare this map, we're looking more specifically at New Jersey here. And if you're familiar with a geologic map of New Jersey, you can see that it's not quite correct, but he did get the broad swaths of geology, especially in New Jersey. I can't speak for the other areas because I'm not as familiar with the other states' geologic maps. But if we look at New Jersey, if you learned, we have 4 geologic provinces of New Jersey, and you can see that it is divided into the 1, 2, 3, and then 4. We have this yellow area, which today we know is the coastal plain. So even though it's not great, it's a really good first estimation of where these units are. So remember, all of these attempts to classify by how they were deposited are influenced by the work of people like Lyell and Hutton, and also Nicholas Steno, who came up with the laws of stratigraphy. All of that stuff happened earlier in the 16 and 1700s. And so they're laying the foundation of how scientists and geologists look at the rocks to put them into a chronologic order. So at this point, we're not talking about what we call absolute time, where we put numbers on things. But so that's what he was doing. He was calling the primitive rocks. He was recognizing based on laws of superposition and other laws of stratigraphy that those are the oldest rocks. And then, so I'm assuming what he meant is these yellow ones he recognized were deposited at a much later time and would be the younger rocks. So again, a lot of work still needs to be done in these maps, but it's a really good first stab at it, given what they knew at the time. Okay, so this is the book that those maps were published in, Parker Cleveland. This is actually the very first geology textbook in 1816. You can see pictures of the spines of it, mineralogy and geology. And there's lots of, classifications of minerals along with geologic maps, some of the basis of how we think of geology and study geology today. So in the early 1800s, this is when geology and the study of this as a formal science started to become more popular. So as they were realizing that this could generate jobs in terms of mining and that there was economic value in this, journals started publishing articles on geology, and more importantly, different states started launching their own geologic surveys. So in the 1830s, we have the launching of the New York, the Pennsylvania, and the New Jersey Geological Survey. So this is all because they want to start studying in more depth what the rocks are around them and how we can systematically study that to understand our surroundings, but also use them for resources. So along with this time, we also have the rise of things called cabinets of curiosities, or Wunderkommens, you might have heard them called. And these were kind of catch-all museums that were really popular in the 1800s, where people would collect natural curiosities from all different backgrounds. So you can see in these pictures, there's shells, there's rocks, there's fossils, there's skeletons, there's, human artifacts, there's, plants and taxidermy animals and everything in between. And so they would stuff them into these, museums and to put them on display, and people would come and look at these collections. So these are really where the natural history museums were born, in these cabinets of curiosities. Again, a lot of these were just the collections of rich upper class people who collected these as hobbies and then put them on display for people to come and see. Some of these were displayed as through the geologic surveys or the natural clubs, natural history clubs. But again, you can really consider these Wunderkommens as the birth of natural history museums in the 1800s. So other thing that was happening at this time is that the public wanted to know more. They wanted to hear about geology. They wanted people to talk about it. So there was a demand from the public. So not just people, students, but the public around universities to give lectures on natural history. And you can see these are actual images of some public talks that occurred in New Brunswick. I see, but I don't know if it has the year on this, but anyway, these were things that advertised, you know, a lecture that people could pay to come see, and they would hear about this. And the important thing is that a lot of times the students were the ones requesting this content because they're at these universities and they were missing their education in the natural history side of things. So they had chemistry and they had other more of the traditional sciences, but there wasn't something that brought it all together, which, you know, natural histories or geology. So if we go to Rutgers, all of this is happening around the university, but how does this affect Rutgers specifically? So in 1829, John Finch, who he comes from, I think he comes from Great Britain. I'm forgetting at the moment which area in Great Britain, but he comes from there. He was teaching there. He came to the United States and he notified sorry, I keep moving my desk, the president of the university at the time, that he was available to teach a course on geology to the students, because again, the students were asking for something to be taught to them at Rutgers University. So it really was the students who led the initial development of geology courses at Rutgers. So in 1830, there was a request to the university from the student-run Society for Natural History to get funds to have a reception and also create a cabinet to put on display the various samples that they were had collected and wanted to display to the students and other people that came to the university. Oh, there it is. He's an Englishman. Sorry, I didn't see that. So yes, John Finch was hired at the time, and he taught the first lecture series of geology at Rutgers, and it was a 15 lecture series on geology. And this also created the first collection of geologic specimens at Rutgers University. So again, this picture of the rocks is not what those rocks were. We do not know at this time what those original samples were that were in that first cabinet, but they were housed in Van Nest Hall, which you can see a picture here. That is the building directly next to the Geology Museum. And so this is actually what we consider the birth of the museum. So the museum hasn't started yet or been built or even thought of yet, but this is the birth of it because this is the first record of the collections being on display someplace at Rutgers. So in 1830, after John Finch gave his lecture series on geology, the university actually decided not to hire him as a university professor, but they went with this guy instead, Louis Beck, and he was the first person that was hired to teach geology. So his title was a professor of chemistry and natural science at Rutgers, and so he taught like chemistry and mineralogy to the university. So he was trained by many of the early famous geologists in North America and United States. So he came from Rensselaer Tech in New York. A large amount of the early influential geologists were trained there, and went to other places later. So his interest in geology was piqued when he was working on the Erie Canal as that was dug. He was taking notes and collecting specimens along the way. And typical of the early geologists, he wasn't trained as a geologist, but he kind of did it as a hobby. So this time, there were people who, they might have been a chemist, or they might have been a doctor, they might have been a clergyman or professor, something else, but their interests were so broad that they kind of dabbled in a little bit of everything. So he was more of a chemist. He was a botanist, a chemist professor, but he learned about geology through his work of mineralogy and chemistry. And at one point, he actually worked for the FDA. So he kind of was a jack of all trades and did a lot of things across, very broad areas at the time. And again, he taught mineralogy and geology as part of the natural history and chemistry at Rutgers. So he actually published in the Geology and Mineralogy of New York and New Jersey. And he actually amassed a more than 3,000 piece personal collection of minerals. So this collection of his minerals is the oldest scientific collection at Rutgers. We still have this at the university. We have this on display at the museum. And we have many samples still in storage. And these samples were put on display in Van Nest Hall on that very first cabinet. So this collection was shown to visitors to the university, to outside professors, to students, to everyone, because it was really the embodiment of what the science was at Rutgers at the time. So it was really considered a gem of the university. And so there's specimens from mostly New York and New Jersey, but they do come from all over. We do actually still have the original handwritten tags with many of these specimens that Beck wrote. And you can see in this picture here, there's the specimen where he labeled the rock as well. And what this picture is showing, I know you're not able to read these, but these are his journals that are still in the archives at Rutgers. So I worked with a historian who went through his journals and found dates and times and locations that he wrote about in his journals. And we were able to match them to some of the mineral specimens that we have on display. So these are, quartzes, and I think this one has some talc in it, some other minerals. That we have the historic record of him writing about it in his journal and the physical specimen as well. And many of the places that he collected these from no longer exist because they were places in New York and New Jersey that were being excavated or dug out in order to build something on them, and they've been built over since. So these really give a historic view of the area that is just no longer available. Okay, so someone most people have heard of, if you are from New Jersey at least, or familiar with Rutgers, you've heard of George Cook. So George Cook was hired to succeed Beck after he retired. So he came to Rutgers in 1853. He was also trained at Rensselaer. Like I said, there's a lot of early geologists trained at Rensselaer Tech. And he came here to Rutgers. But he actually taught at many other places. I don't remember off the top of my head the other places, but he was teaching at Rensselaer. I think he was teaching at a private school as well. And the Rutgers offered him a package, I think, and some money to do research and collections to come here to New Brunswick and New Jersey. So he was given an honorary doctorate from Rutgers in 1856. So he didn't do a dissertation. He wasn't trained the doctoral way for his PhD, but he was given one by Rutgers, which speaks a lot to his level of knowledge at the time, because there were no earned PhDs in I think at the university until 1863. So the fact that he was given an honorary PhD before that speaks to how influential he was at the time. So he also became the state geologist of New Jersey in 1864, and that is a position he held until his death. And this is something that's even at Rutgers is not well known, because Cook campus is named after him, which is considered the agricultural campus. Most people think that his primary influence was in agriculture and that was his background. And that's just not true. He was a geologist by training, and he was a geologist first. So when he first came to Rutgers, his first title was professor of chemistry and natural history. And then later on, as after land grant status, which I'll talk about just in a minute, that's when the professor of agriculture got attached to his name. So all my Cook people, he just need you to know he was a geologist before he was an agriculture person. Anyway, so more about Cook. So when he was there, he was also a vice president of the university. And so in 1864, after the passing of the Morrill Act, which is to grant land grant status to universities in the country, he came up with, he started to lobby the university and the people involved in the university to advocate for Rutgers to become the land grant status of the university. So as we know, they were successful in getting land grant status. They were granted the status in 1864, and they were competing against against Princeton and the State Normal School of Trenton for this status. But Rutgers was selected instead of the other two schools. And as part of the agreement to become the land grant status, so this is where Rutgers would get money from the federal government when they sold lands under the land grant status. But in order to get those funds, the university had to make certain improvements to the scientific school before they could get any of those funds. So that is why several things were done and proposed. So this led to the Rutgers Scientific School being established in 1864 as well. And they had to provide facilities for these programs to exist before the money could come from the federal government. So the first thing that they proposed to do is if you look up here, it says faculty committee proposed an observatory with astronomy equipment and a place for scientific instruction. So this is kind of what we think of as the first proposal for the museum. So what came out of that proposal is two things. We have the Shank Observatory that was built in 1866, which I'll show you a picture of in a minute. And then also the Geology Museum was built to meet the requirements of that land grant status. So the museum has always been in that building and has always been in the same space that it is since it was built 150 years ago, but it shared the space with other departments. So the building was home to geology, physics, and military science. So the main part of the museum has always been the part to display the collections. The first floor is when there were lecture halls in that, and then in the basement of our building was an armory for the military science part of it. So all of the geology courses that were taught at the time were taught under the chemistry and agriculture program in the scientific school that was started because of this. So these are just pictures, some older pictures showing what these look like. So here we have the Shank Observatory, which there was a telescope. I'm not going to talk about it now, but just went through a couple years ago a beautiful restoration project where it has restored it to its what it looked like when it originally was built, along with its rotating roof, and they have the original telescope now, so it's beautiful. And I maybe we'll have them talk about this project later on in the year. And then here we have the Geology Hall, which again, one of our later today speakers will talk about the architecture and the building of that. So some other things that Cook was influential in, yes, the museum would not be there without him, but he also was an avid collector. He collected over 4,000 pieces and added them to the collection. We do have many of those pieces on display at the museum today. He collected a lot of big tree fossils from Pennsylvania that are in, we have these giant tree stumps that are in the corner of the museum. They have probably been in the same location since George Cook put them there because they weigh so much, but they are from his collecting. The other big thing that he obtained was the Mannington mastodon, which is our Manny, who's our favorite fossil and our, kind of our mascot for the museum. But he purchased the skeleton in 1870 for $300. It was found on a farm. I'm sure I'll remember later, but I cannot remember right now the name of that farm. But he purchased the skeleton from that farmer for $300, and there is a copy of that receipt somewhere in the archives, which I have seen a picture of it before. However, George Cook never saw it on display in the museum. It wasn't mounted until 1892, so after he died, but it has been on display since 1892. Okay, so what are some other, just look at the other museums in the time. I told you that there were a lot of personal collections of, Wundercommons and cabinets of curiosity on display at the time. And, these were self-run, or they were lyceums from mineral societies and things like that. And so there's a lot of records of these early places, but it's really hard to find all the records of them because there were so many and they were run by such small things and they were often absorbed into larger ones. So it's really hard to get an exact chronologic order of when these occurred. So around when this all happened, this is when geology started shifting away from that citizen science collection more towards university collections. And so a lot of those little personal collections were purchased or transferred to other places. And things like the Peel Museum, which is a very famous one of these cabinet of curiosities, they were able to stay open, and all of their collection went to the American Museum of Natural History in the 1790s. So from what we were able to collect the data, here's the years of when we see museums, actual museums being open about natural history and mineralogy and stuff. So you can see, a lot of these other museums were opened before the museum, our museum, but ours is the first one that is specifically named after geology. So that's why we give ourselves the name of the first geology museum in the country. And we are proud of that and continuously operated since that time. This is another very proud accomplishment of the Geology Museum. So some other things that happened in the early years of the museum. So A.H. Chester is another one of the early curators of the museum. He started his career at Hamilton College until 1891, and he came to Rutgers after Cook's death, and he was hired as the first museum curator. And he also was an avid collector. He collected more than 5,000 specimens that were donated to the museum after his death. And in that picture above, you can see some of those minerals that you see in that picture are from the Beck collection. And so we do have many of these samples and his handwritten tags as well. So he was an avid mineral collector. He worked a lot with the state of New York to relabel and reclassify their collections. And I'm pretty sure he had I can't remember the name of it, but he published a book on mineralogy as well. This is William Valiant, which I'm not going to discuss because our later speaker will be talking more about William Valiant, but he was responsible for many of the things that transformed the museum into what we see today. So here you can see him standing next to our spider crab, which was, I think it's 1899, or it's right around the turn of the century is when the spider crab came to the museum, which was on display until the 1980s. And then taken down for disrepair, but it is now back at the museum. If you've been there since, I think, 2015, you've seen it on display back in the same spot that you see Valiant standing next to it here. So when the museum was first open, the museum was where the courses for geology took place. There wasn't a geology department yet, so it was still the chemistry and natural history kind of together. But the way courses were taught is that the students would come into the museum and they would learn the subject by observing the minerals, by observing the fossils, by observing everything that's on display here. So they would come in and they would look at, this is very typical of what collections of the time looked like, where there would be large displays with lots and lots of specimen of like the same type, but slightly different, so that they could look at the differences and classify them. And I just love this picture of the interior of our museum. And you can see in the back, you can tell it's ours. You can see the spiral staircase right here. Unfortunately, we do not have the whale that originally hung from the ceiling. I also find it fascinating that there was this crocodile something or other. I have no idea. When we first saw this picture, I was like, what is that? Where did that go? Why do we not have that? So I don't know what happened to that. But the whale, I can tell you, people always come in and ask us about the whale. Where's the whale? I thought it was hanging from the ceiling. So the whale originally came to the museum. From what I had read and heard, it washed up in the Raritan, and beached, and it died. And so that's how they acquired the skeleton, and then they put it on display. So this is it's a right whale, this type of species. However, whale bones are very fatty. They have a lot of blubber and stuff inside them. And if they're not preserved properly, they basically rot from the inside out. And that is essentially what happened. So one, it was very heavy on the ceiling, but the more important thing is that it was rotting. And so they took it down, and people ask us, oh, I heard it's in this basement. It's some urban legend about what happened to this whale. It's not true. Sorry to disappoint. We do not have it anymore. It was given to Yale a long time ago, and they tried to preserve it or to save it, but they couldn't. It was too far decomposed, so it was actually disposed of. So we don't have this whale specimen. It is a dearest wish of mine at the museum to one day put a replica whale skeleton back up on the ceiling. We just need a really big donor to come and buy that skeleton for us. So hopefully before I retire, we will get a whale skeleton back on the ceiling. And this is just another view of the inside of the interior of the museum. And again, you can see all of those cases lined up with all the specimens. And that's how the geology was taught in natural history at the time, by observing these objects, by visual scrutiny of the objects. And if you've been in the museum, the windows are very tall, and they are lined up so that the sun follows the building. So in the morning, the sun is on this side of the building, and then the afternoon, the sun's on the outside. So that's to provide as much light as possible to observe and look at all those specimens, because there was not lighting originally in the museum. And again, just another view you can see of what they originally looked like. Another thing is we do not have those original cases anymore. They also fell into disrepair, but hopefully one day we will be able to get cases, replica cases that look similar to this, that have that Victorian feel. But again, you can see in this picture, I'm pretty sure on the wall right here, those are the dinosaur trackways that we have on display. You can see they're up on the wall. Now we have them flat with a dinosaur on top of it. Okay, so in the early 1900s, and then, so the department's growing. We don't have a department yet. We don't have an official geology department until 1931. Okay. And Albert Hayes, which you can see in that picture, this one right here, this is Albert Hayes under the mastodon. He's the first department head of geology, and he's responsible for expanding the department a lot and creating more courses and things like that. So one of our other more influential department heads is Dick Olson, who was actually a co-author on this paper. You can see him right here next to our mummy. He was responsible for really transforming the department into the research-based department that it is today. And so, today, the faculty still work with the Geology Museum, but the department is not in the museum anymore. So when this was in the early 1900s to 1977, the Geology Department was in the museum. So Dick Olson, his office was in the Geology Museum until 1977, where the Geology Department was actually moved out of the museum and across the river to Bush campus. So we still work with the Geology Department, but we are not intimately connected like that with them anymore. And our first open house, like we have today, was held in 1968. And so these pictures, this one, these three here, these are pictures of the first open house that Dick Olson pulled out of his drawer. I was meeting with him to write this paper, and he opened a drawer and handed me this pile of pictures. He's like, oh yeah, these are pictures from our very first open house. So you can see, it's very much in light with how we have our open house today, where The professors and scientists meet with the public. You can see tables out. I don't know if this is a mineral sale or if this is just a show and tell of minerals, but people coming to the museum and checking out what's on display. And then this is another picture later on of Bill Selden, who acted as the curator for over 30 years before he retired when I came in to work at the museum. So today, I know there's a quick history. Our museum doesn't function as a research institution where, that kind of how it was in the early 1900s, late 1800s, where everything was taught around the collections and everything was done in the museum. So we are more of an outreach and education center. We do all sorts of events, bringing students and adults and everything in between into the museum to learn and learn through the collections and, be inspired by the specimen that they see on display. So I just love this picture. This is someone sent this to me. It's from the 1970s of kids standing underneath the mastodon looking up in awe. And that is a sight that we see pretty much on a daily basis when kids are coming here, is looking up at this mastodon and being wowed. So anyway, I will answer questions now, but before I go to questions, I just wanted to show you this. So if you want to learn more about this history, I gave you a brief overview here, but this is the paper that we published a couple years back. It's posted on our website, but you can scan this QR code and download the paper to read the full story about the Geology Museum history. So let me stop sharing. Okay. All right, let me get to the questions. Okay. Can I show the swag once again when you are full screen? Yes, I can. So here's our sticker. Okay, which again, it's not square, it's around the shape. So this is free to anyone who becomes a member at this moment. Or we will sell them online as well, but we're not ready for that. Here's our wonderful geology hat with our 150th logo. Okay. And then my favorite, which I'm super excited about, is our canvas tote bag with the logo as well. So Rutgers only allows you to have a logo for events like this. So we were super excited to be able to have a a logo for our 150th. So we will be using it for everything we can until they tell us we can't anymore. So for 1 year. So Mona would like to know what type of whale used to hang from the ceiling. So you guessed baleen whale. So yes, it's not a baleen, it's a right whale, which is a specific type of species. And yes, like I said, hopefully we can get that back at some point. Where are the oldest rocks in New Jersey and what kind would they be? So the oldest rocks in New Jersey, so geology of New Jersey, essentially from the northwest corner of New Jersey down to the coastline gets younger. So the youngest sediments are that, if you remember that map I showed you that was all yellow, the bottom part of New Jersey, which is the coastal plain. Those are all the more recent, basically since the last couple million years. And then as you go up to the northwestern corner of New Jersey, where it hits New York, that part is much older. So those are the oldest. And oh man, it's been a long time since I had to pull these figures out. But there are schists and metamorphic rocks up there that are billions of years old. I'm totally blanking. Maybe someone can Google someone behind the scene and put the answer, because I am totally blanking on the ages at the time. Okay. Pete would like to know about when were those old original mineral specimen displays cases removed and replaced. I don't know the exact time. We had them for a while. I want to say maybe the 70s or 80s. There was, Ken Miller, thank you. 1.2 billion is the oldest in New Jersey. I knew someone would come through when I When you forget, your IQ goes down when you go in front of a group of people to talk about something and you forget common things that you didn't remember before that. So thank you, Ken, for providing me that number that I couldn't remember. Okay, so the cases, I don't know exactly when they left, but we had heard that there were some of the cases given to the Sterling Hill mine a couple decades ago. And Missy Holzer, thank you, says her father was there when the cases were placed and grew up in with their house. The ones they had were donated to the Sterling Hill Museum. So it was recent, but I don't think the Sterling Hill has them anymore. So, you know, we have the pictures, and our hope is to use those pictures and hopefully get renovation money to replicate and have them look very similar to what they were. So yes, thank you. Missy says it's sometime in the late 70s, so which would have been my guess. Okay, so do I know of any other Victorian style museums that still exist? Yes. So the Peabody Museum, Yale's, is a great place. And Missy says they're still at the Sterling Hill mine, so we'll have to go check them out at some point. Also, there's the Wagner Museum, which is in Philadelphia. They have a wonderful display, and it very much looks like those early pictures I showed you of those early cabinets of curiosities. But those are the two that come to mind. But yes, I highly recommend checking those museums out. And I'm sure Dr. Carla Liani will have a whole list of those type of museums in her talk later this afternoon, because that's what she knows about. As the first geology museum in the US, did the RU Geology Museum play a part in any excavations, or they purchased collections from others? I'm not aware of any excavations. It's possible that collections were acquired. We have had certain collections donated to us over the years. The most prominent would probably be the Hirshhorn collection, which is fluorescent minerals from Sterling Hill. We don't acquire like museum quality collections. Sometimes we get a lot of personal collections, but we haven't gotten ones from like big museums and things lately. But they, you know, there have been ones that are acquired over the years. Okay. Lauren would like to know, how were students selected to be part of the program? So I'm not sure what program that refers to. I'm not sure. So programs at the museum that we do. So we have programs going on all the time that you can sign up for and come in person. And, you know, if you're a Girl Scout, Boy Scout troop, school, you can sign up for tours. If you're a student at Rutgers or even outside Rutgers, we have done programs and internships with them that, again, you reach out to us, and within our capacity, we are able to host interns. We actually have a very young intern. I don't know if you follow us on social media, but we had a student, Cole, who was fantastic, who was helping us with our social media posts last year. And I think Cole's in middle school, maybe high school now, but I do not remember off the top of my head his age, but he did a wonderful job. Tatiana says, the article, An American Cabinet of Curiosities, offers a thoughtful reflection on our early effort to create a cabinet. Thank you for that. I will check that one out. So where was the mastodon found? So yes, the mastodon was found in Mannington, New Jersey, on a farm. And like I said before, I'm completely blanking on the name of the farm. Hackett Farm. Thank you. The chat, I knew it was an H, but I knew if I said it, it would come out wrong. So yes, it was found on the Hackett Farm in Mannington, New Jersey. Thus the name Manny, the mastodon, which that name Manny came before there was Manny the mastodon, or Manny the mammoth from the Ice Age movies. So it's not named after that Manny, it's named after the place where it was found. What kind of rocks are underneath the museum? Did they find any fossils when they were making a museum? So the rocks by the museum are red beds. So they are Triassic age red shales. And you can find fossils in them. They're mostly footprints, trace fossils. So these are very similar to the fossils we have on display in the museum. And I've heard that there are some preserved dinosaur footprints somewhere on campus, but I don't know where. No one will share that information for fear that somebody will damage them. Yes, the Passaic Formation. Thank you, Ken. Ken's my New Jersey geology expert that knows all this stuff. I haven't had to memorize it since I took his class 20 years ago. So I don't remember all the fine details of those. Okay, do you have artifacts in the vein of other natural history museums such as pottery? So yes, there are, so just with the nature of how collecting was done in the 1800s, they didn't collect just fossils and minerals, they collected like all natural history. So this included like stone tools and things like that. So yes, we have a pretty large stone tool collection as well. And there are some other artifacts, some Indian artifacts, and some Egyptian artifacts that are on loan to us from the seminary at Rutgers. So yes, it is very much like that all early natural history museums had collections from all different natural history fields, including anthropology. So Eric asked, has the museum worked with dinosaur findings in New Jersey like the Hadrosaurus? We haven't been involved in digs. We do have things on display. So there is one footprint on display at the museum, which I think is the only Cretaceous age footprint preserved in New Jersey. But we do have a Hadrosaurus bone on display, but because we are not a paleontology research center, those type of things would be done at possibly in places in Philly or Stockton, things like that. So we don't work directly with those. So someone asked, if a member donates quality mineral fossil specimens, is it possible that specimens might be displayed in the museum rather than being sold? Yes, and that is something we do. We do have things on display that have been donated from members. So yes, we're always accepting donations. If you have something beautiful that you would like to have on display, we would love to put them on display. Again, there's small amount that we actually put on display that's museum quality, but yes, we'd be happy to talk to you about that. Thank you for asking. When were women first admitted to Rutgers? So thank you, whoever looked up the answer. The first class of 42 women graduated in 1922. So thank you for whoever Googled that answer. Sue would like to know, can the public get online access to written materials in 1800s from Rutgers professors? That I don't know. That would be a question for the libraries. So the archives, and I don't remember which division, but they're the ones that have those materials. You are able to view them in person. I don't know how much of it they have digitized, so you would have to reach out to the libraries. And again, this is how we completed a lot of the research for this project, as we went through the archives, went through the journals of Beck and things to put some of this information together. And I think that was all of the questions. Yes, special collections and university archives. Thank you for giving me the name. I couldn't remember. But yes, they're the ones that you would have to ask. And I don't know what they have. And again, same with all of us, COVID has put a hit in what work is being done towards this. But I'm sure they have some things digitized, but I don't know if they've digitized everything from the museum portion of their archives. And I think that was all the questions. Thank you everyone for listening. I feel like I've blabbered on forever, but thank you for, oh, another question. Does Rutgers offer public geology tours? Yes, we do. We haven't recently because of COVID. But yes, follow us on Facebook, sign up for our mailing list, and you will get notification for when those things occur. Hopefully we'll be able to do some of those things later on this semester. But yes, we do things like we go take people on fossil digs to Big Brook. And yes, but hopefully we'll get back to that soon. So thank you, everyone. And we will be back at 1 with our next talk from Anya Pearson, which I'm super excited about. She's going to be talking about Mary Anning. So we'll see you all in a half hour.